If any of you have been wandering through the show floor, either at this show or maybe even some previous shows, you may have noticed what we call this guitar tuning demo. But one of the things that I think is interesting here is not just the fact that here represents, just like at my home office, a bunch of guitars that I can't play. This here is actually a very good demonstration of the storyline that is being told across the entire Cisco event. So yes, it draws the eye, that's a good demo. But the story that it tells, that's what we need to understand. Because what's happening here is obviously robotics and its guitars, maybe a little bit unnecessary, but what it does is highlight the communication paths, the necessity of how do we take existing architecture, and we're in the IoT, the industrial side of things here, a lot of older networks that need to support new AI-based workloads. We're not going to change that whole network, so we have to incrementally adjust and bring the future to the network, so to speak. I don't know if that's the right way to say it, but I think it sounded good there. So as we look at this, we're coming around here, I want to talk to Fabian, because Fabian, I did not trust myself. Oh, I'm remembering how I was told to walk around here, my apologies. Fabian, thank you for taking the time. You're responsible for this demonstration as I understand it. We've got a lot of different elements at play. Help us understand the story that's being told here. What's important to walk away with?
Yeah, so what we're trying to demonstrate here is how we can help all these industrial organizations to move their industrial processes to more and more software, to control not only the machines and the industrial processes that they have in their factories or in their industrial plants, but also how they can use more and more AI to support their production infrastructure. So you've seen on the other side the robot arm playing the guitar to help tune the tone of the guitar, so that requires software to analyze the music, etc. On the other side of the pod, we have also cameras doing machine vision to analyze if there are any visual defects on these guitars, and all that requires a pretty powerful network to transport all of these flows to power also the cameras, that needs PoE, etc. And also a lot of security built into the network, fused into the network to make sure that the machines are behaving properly, that there's no threat into the infrastructure to disrupt the industrial processes. And so that's what we're doing with our ruggedized industrial Ethernet switches, with all this security built in, etc. Yeah.
Well, tell me about the components for anyone that already understands Cisco, but they're like, well, what's really behind this? You've got the industrial Ethernet, the 3500, I believe.
Yes, the 3500 is one of our industrial Ethernet switches. We have various products in the portfolio to meet any needs. Okay. The beauty of this platform is that they can embed some cybersecurity features to understand what's going on in the industrial network. If there are any intrusions, what are the assets, what are the vulnerabilities, and also they have a lot of the specific capabilities that the manufacturers require to power their assets, with high wattage PoE, with a lot of throughput also to support these AI workloads, and the very low latency to enable software control to the machine instead of having everything based into proprietary hardware.
Yeah, tell me, so obviously, we're using audio monitoring as well as the video monitoring in terms of this, but in a real factory setting, that latency that you speak of when it comes to AI workloads can be, can cause things to completely fail, can run up a lot of money, that type of thing. What would be an example of when this is not operating correctly because of some of the missing components, perhaps? What happens?
Yeah, exactly. The key in industrial network is how all these machines are synchronized, how they behave together to build one industrial process. Yeah. So each of the machine needs to be very timely synchronized with all the other machines. So if a guitar moves from one point to another, then the other machine is ready to get the guitar and do things that it's supposed to do on the guitar. All of the time synchronization is very key, and that requires very low latency networks to make sure the robots, the conveyor belts, all the machines get their instructions in a timely manner. So the network needs to be very reliable and also have very low latency, for sure.
Yeah, I find that fascinating because I feel like it's a carefully calibrated orchestra, if you will. Now, a lot of that, of course, we need our confidence that comes from good dashboards. I hadn't seen this dashboard before, and you're like, well, no, we created it because that's what Splunk allows you to do. Can you explain kind of how cool is that? The guitar just goes, I'll show myself in front of the screen. do you mind explaining what we're seeing here and what's important to understand?
Absolutely. So that's a dashboard that we created using Splunk to aggregate, to blend into one user interface all the telemetry, all the information you have from the various components part of this manufacturing process. So on the side here, you see all the production telemetry about how many guitars has been moved around, what are the defects, what is the audio quality, etc. So that's really what a production manager would be interested in seeing. On the other side here, you have all the telemetry from the network, from the firewalls, from the security products that we have in the environment to understand the health of the network, if there are any vulnerable assets, etc. And also here on the bottom, you see the power consumption of these various machines. So you see in one single pane of glass, the plant manager or the whoever is responsible of the industrial process can monitor both their production information and their infrastructure and security information. And if there's any error, then the dashboard will blink red to tell the person to go take action, etc.
So despite this being all fancy, and I don't know, I doubt they can hear it because there's this low frequency hum over here, and you can feel it when you're on there, and I've had to be careful because this is a very physical demonstration. It feels quite consequential. It feels heavy and such there. How does, this is fancy, but what's the reality of customers deploying the technologies here in their own environment? How do they ease into this type of thing? What do you usually recommend?
So generally what they are all doing now is migrating their industrial network to a network that's more managed, so they can better orchestrate all these industrial processes, increase the throughput of their production lines, because the faster the network works, the faster the machines can work as well, and the more products get out of the production lines. So being able to build a faster network that is easier to manage, easier to reconfigure when the production needs to change is really the key right now.
That's incredible. Yeah, the flexibility that you talk about there, especially when we talk about the platform advantage, you invest in the switch, but the switch can be configured to support some of the visibility that we need and some other things. Yeah, that's incredible.